A very warm good afternoon to Honorable Speaker and members of AWS, esteemed faculty members of UPS, and all the attendees. I would like to extend a warm welcome to the first webinar of AWS Learning Series powered by AWS Educate in collaboration with UPES CSA. Topic for today's webinar is AWS Well-Architectured Framework, and our speaker is Mr. Saurabh Bhattacharya. Before introducing our esteemed speaker, I would like to tell about our chapter CSA. It is the only chapter of UPES which is cloud specific and is collaborated with the CSA Uttarakhand chapter. Now, let me introduce to our honorable speaker, Mr. Saurabh Bhattacharya. He is AWS Certified Solutions Architect, Associate, AWS Solutions Architect Professional, AWS Certified System Ops Associate, and many other certifications are in his banner. Overall, 16 plus years of industry experience in both India and abroad. Worked as hardware, uh, hardware support, network administrator, team lead, pre-sales consultant, and technical advisor, sales and BDM, technology evangelist, technical manager, senior technical instructor. His hobbies include traveling both within India and abroad. He has traveled 5 continents extensively. He also likes to listen to music and he's also interested in sports. Now to our speaker.
Hello, good evening, everyone. Just a quick check if you all are able to hear me. Are you all able to hear me? May I have certain responses on the chat, maybe? Let me see how many of you are awake. Oh, yes, there are a lot of people who are typing yes. Great. All right, so shall I share my screen now? Okay, I believe I need the rights to share the screen. All right, just give me a moment. Let me try to share my screen and take you all through this particular session. Awesome. So this is the first in the series which you all saw. This is around AWS architectural patterns and best practices for serverless architectures. You already heard about me, overall 16 years of industry experience working in both India and abroad. And again, traveling is the hobby, as you saw. Apart from traveling, reading and listening to music, I have traveled close to 60 plus countries in this world, and some countries multiple times. So you might have heard people saying airports are their second home. Probably before these socioeconomic times, it was my first home. A couple of certificates from the AWS specific, which you see at the top. And then apart from AWS, I do also possess VMware and Microsoft, and some storage and networking certificates as well. So that's about me, and I hope you all are able to hear me properly, and you are able to see the slides as well. This is gonna be roughly 50 minutes or so session. What we are getting into in this particular session, and what's in it for you or for anyone. This is a level 300 session. I was thinking when Vitesh asked me that, sir, could you conduct a session? And I was just thinking, we do conduct a lot of sessions, a lot of marketing sessions. You all have access to a lot of resources with you. And I was just thinking how I could conduct a session which is a little bit different. So there are umpteen number of level 100 and 200 sessions which are being conducted by our marketing team, training and cert team. There are some community outreach programs as well where all these sessions gets conducted. And what we need to understand is in this session, I have made it a little bit advanced. And again, by all means, what you need to understand is we need to aim for the moon. And when we are aiming for the moon, and if we want to reach to the moon, we have to go and try to aim for the stars, right? That's how they say it. And about serverless, what you need to understand is, and why I have chosen this particular topic is because see, the whole world, as I have seen, technically speaking, is divided into three parts. All right. The first part is where there are advanced countries which adopt the technologies quite early, and we call them as technology adopters or probably early adopters of the technology, right? And then we have countries like our country, like India, who are technology followers. So we follow probably US and Australia and Japan and some part of Europe and these countries. What we need to understand is what a lot of people in India, I have seen a lot of students in India, what they have started focusing on, the basics of like EC2s and the S3 and a lot of other services in AWS. And I was just thinking that, okay, I know this is like bare minimum or the foundations. However, what we also need to understand is where is the world sitting today, and what we have to expect in the couple of years down the line in India. Because if I look at, let's say, the advanced countries, most of the companies who are on cloud, they are adopting serverless models. So for anyone out there who doesn't understand what is serverless, I'm pretty sure you all have seen servers, or you might have heard about servers and all. This is where you call it as web servers and application servers and database servers, and we talk about those systems. The point for serverless means there is a system behind the scene, but then you are not managing that system, right? So system is there, but then you are not managing it. And I can put it in a different way, in a simple layman terms. Imagine that I'm in Hyderabad and I want to reach Delhi, and let's say this is my goal. I have two options. Option number one, I can buy a flight ticket, I can fly there, right? The second option is, and let's say I need to reach there today itself, so that means train is out of picture, and then I cannot go via road as well. So flight is the only option, right? So I can buy a ticket and I can go there. But there is a second option as well, and that second option is, if I am a pilot, let's say I know how to fly a flight, I can fly it and then I can still reach there. The question is, what's your goal? Is your goal is to fly the flight and then reach Delhi, or is your goal is just to reach Delhi? And this is the exact difference between serverless and the on-prem physical environments which we all are aware of. So this is where the whole world is heading towards. All right, serverless. And advanced countries, most of the companies, they are already on serverless. They just want to focus on their goals, right? They don't want to focus on buying the hardware and then installing it, and then making it highly available and secure and performant, and all those patches and updates and upgrades. All those things people don't want. They basically want that particular service to run, right? And they don't want to take the headache of managing the servers. And that's exactly serverless for you, right? So here is the question, okay? And this is something where I need to check how many of you did understand serverless. Is that, when was the last time, and this is where I want all of you to reply it on the chat, when was the last time you installed an operating system manually? Can you all type your answers on the chat section quickly? I'll give you like maybe how much? 5 seconds? 5 seconds. When was the last time you have ever installed an operating system manually? Or have you ever done that? I mean, I'm pretty sure, some of you might have received a pre-installed laptops or maybe systems. Not sure whether you have ever done that as well or not, right? So this is the exact thing. If you ask me, whether you install an operating system manually from that CD, DVD, or maybe, you get a pre-installed operating system, it doesn't matter. Nobody cares about it, right? Because as long as your application runs, nobody cares about OS, nobody cares about the hardware as well as your application is up and running, it is running performantly, it is running securely, you are happy, right? And that is what serverless is, and that is what we will focus on. So when we talk about the well-architected framework, what we need to understand is, I'm pretty sure many of you might be developers as well, right? Most of you might be coming from engineering background, or some of you might be into, other programming languages. And what happens is, if you try to build a program, and we all could do that, if we know the basic underlying syntax and the architecture and the logic, we could do that. The problem is, while we are building up that application or that program, we somewhere lose a sight on, is it well architected or not? Because see what happens in a typical company, whether you work for a company today or you don't, and tomorrow you might be working for some company where everybody will do planning. They will do lots of analysis, they will create a design, they will try to implement it, they will test it, they'll integrate it, and then they'll try to maintain it. The whole cycle, if you look at it, the whole software development life cycle, one question, if you start this question towards the end, you might be in for a doom. And why I'm saying that is because there are many things which starts right from the scratch, and you might have to implement it right from the scratch, right? So this is a most important question which you need to ask. Are you well architected? And what do you mean by well architected is that, why we even think about well architected? First, it is something which will help you to accelerate your cycle, the development cycle of your software. That means you'll be building and deploying the applications or softwares or their versions and revisions faster. It will lower or mitigate the risks because you are proactively will think about what could go wrong, and you are kind of having a framework in front of you with which you can go ahead and put everything as per that framework, so as to speak, so that you don't go wrong. You will make informed decisions, because see, when we talk about security, for example, security is job zero, and I believe it should be job zero for anyone and everyone, no matter who you are. And if we try to integrate a username and password in our source codes, I don't think we are off to a good head start. Am I right? Because if somebody, let's say the security team, will validate that after your entire application is ready to be deployed in production, and that time somebody will discover, hey, you have integrated your username and password. I mean, you have to now think about, okay, how can I not put the username and passwords over there? And similarly, it could be related to a lot of other things as well. For example, you use GitHub, let's say, for source code version control system. And it could be GitHub, it could be CVS Dude, it could be many other version control systems where you put your softwares before your softwares are even ready, right? Before the alpha version of the software. And if these secrets, or maybe think about connection string URL for your databases, if they are already integrated in your source code, you have already compromised the security. Am I right? And that's where you make the informed decisions and you learn the best practices. And that's really important from the cloud perspective as well. So what are the pillars for the well architected framework? And this is to be very honest with you, this is specifically not only for AWS, although this is something which AWS advocates openly, but then I believe this should be primarily for any cloud which you go, right? And what are these five pillars? Let's have a look. Number one, it's operations. What do you mean by operations? The day-to-day tasks which you perform. So imagine there is a hypothetical company, and this company has huge data center, and then this company is trying to migrate to cloud, or maybe this company is something which is born on cloud, right? And how do they do day-to-day operations? What are the things which are involved in day-to-day operations? It's like, how do I deploy my systems? How do I create them? How do I manage them? How do I operate them? How do I secure them? How do I patch them? How do I update them, and all these things comes under operations pillar. And what is the goal here? Should be the goal should be that it should be completely automated. I mean, imagine night 2 o'clock, somebody, is sleeping, and then that person is, getting a call that, hey, you know what, something has gone wrong, something has got broken. And then you got to get up and you got to, in your half sleep mind, you got to go and try to find out what has gone wrong, why this website is down. Let me have a look at the server. Let me have a look at the connections and all these things, right? Can we, anything which you're doing manually, can we write a script and automate it? I mean, I'm talking about bare minimum, right? So how can we ensure that our day-to-day lives starts becoming easy, especially from the operations perspective? So what all things we can do? And trust me, I'll give you a lot of examples and a lot of architectures from the industry relevant, companies, and you will have a look at it and you will understand what I mean here. The next thing is security. Security pillar looks at the ability, how can we protect our systems, how can we protect our data, how can we protect our assets, how can we protect our information. Then comes your reliability. Reliability pillar means even if there is any component failure, including let's say a single NIC card failure, or even if you imagine there is an entire site which goes down, right? Let's say there is a flood, there is an earthquake, there is a fire or something disaster, right? Even then your application should be up and running. So have you incorporated the component, the redundancy in each and every component which you're using, the high availability, the fault tolerance, including till the DR scenarios, the disaster recovery scenarios. And that's what reliability pillar guides us through. Next comes performance efficiency, and this is again pretty simple thing. Are you happy with the performance or not? What are the benchmarks are you looking for? That benchmarking is important. You cannot just go and say that, hey, you know what, this system is slow. You cannot say that, hey, this application is slow. What do you mean by slow? There's no slow or fast. It's a perception. What if your internet is slow and you are experiencing that the website is taking time to load up? So what we need to understand is that, okay, what is the turnaround time? What is the those CPU and memory matrices? What are the utilizations? What are the demands, right? So we need to have those numbers in place, and what we call it as a performance benchmarking. And then last but not the least, the cost optimization. And again, what does it mean? This pillar looks at, especially on the cloud, that how we could avoid unnecessary things, how we could remove unneeded things, how we can ensure that going forward month on month, our AWS bills should be reduced. Let's say you are on AWS. So in that case, how we can ensure that month after month, can we keep on, improve the efficiency? Can we keep on reducing our bills on the cloud, right? And these are the 5 pillars which are important. Now, a lot of you might have heard about the on-premises environments, and sort of on the left-hand side, if you have a look, you will say that, okay, fine, there are many things which we are aware of. So, for example, we are aware of the virtual machines, we are aware of the servers, the storage, all these systems which I see on the left-hand side. Now towards the middle, and this is where a lot of people are talking, they are saying that, okay, we are talking about cloud, which means this is where we have got migrated to, and this is what the whole world is going after. But then, my dear friends, it would be an understatement. And why I say that it would be an understatement is because the advanced the countries, or the early adopters of technologies, it could be companies as well. These companies are focusing towards the right hand side. So if you have a look at the right hand side, this is the serverless part. All right, and I hope you all can see it. This is something where the entire world is focusing. And mind you, my dear friends, maybe 1 or 2 years down the line itself, you will also be thinking about only serverless. Wherever you'll go, you'll hear serverless, you will see serverless. And that's why I thought I will focus more on serverless. Now, one piece of kind of caution, that some of these things, for some of you it might be absolutely new. And again, as I mentioned, this is a level 300 session, which means we will not be able to cover the basics. However, what I would encourage all of you is to keep your notepads and pen ready, and whenever you see any service name which probably you might have no idea about, that's fine. Keep an eye on the big picture, what I'm trying to focus, and then you can just make a note of that service name and later on go ahead and dig deep and then try to learn them. All right, and that is the best way how you can reap the maximum benefit out of this particular session. So let's see some of the patterns, and I'll start off with a saga kind of an architecture, which is for a serverless airline. Now we do have a Amazon State Language, and this is something which will help you to build kind of workflows. All right, so what is this State Language is all about? We call it as ASL, which is AWS State Language. And what this ASL will help you to do is that it will have a start phase, as you can see on the right hand side, there is a start button, and then it will have an end phase. So this is the last thing where your entire workflow will stop. And what you need to understand is, between start and end, you can keep on adding multiple states. So any workflow which you want, think about your flowchart diagrams, right? And you might be aware of it. This is something we could completely achieve using one of our services. We call it as AWS step functions. Not sure whether you have heard about it. If you have not, just make a note of it. But then now focus on this particular slide. For a serverless airline, what we have done is, if you notice on the right hand side, you will see everything which is green rectangles or green boxes. And green boxes is actually the straightforward procedure. Somebody would like to book a flight, and if everything goes fine, then it'll be like super fast thing, and it'll work through, and then the booking will be confirmed. Straightforward thing, right? Now, the most important thing is, what if there are some errors which are encountered? What if some system wasn't up, some system throw an exception? How do we handle it? And that's where you see towards the right hand side, this red boxes, and this is something where you will see all those exceptions could be handled. Now, if let's say the booking failed, or maybe you will try 3 times, or maybe you will try for next 24 hours or next 48 hours or 72 hours, and you want to keep the customer notified, right? You would like to keep the customer informed that, hello, Mr. X, your payment unfortunately have failed, and we will try it for another 2 times or 3 times, and then we will notify you. And if it fails, I'll update you, and then we'll cancel your booking. Right now your booking is on hold, for example, right? So this is something, if you look at this particular architecture, this is something which will be easily attained using this particular diagram. Now, if you look here, there might be a lot of services which you might not have seen or heard about. But then, as I said, focus on the logic, focus on the big picture, and you should be good. One thing, which is the most important thing, which you need to understand, that all these services which I have tried to accumulate here, these are all serverless services. That means you as a customer will never be responsible for managing these servers, for creating these servers, for their availability, for their scalability, for their security. AWS will take care of that. All right. So that's a big headache which is removed. Right now, if you look at this particular example of a serverless airline, towards the left you have a client, and this client could be anything, could be computers, mobiles, or anything. They have an app as well, and they have a website as well, kind of a progressive website. And then you don't require any Lambda function, because the moment an API call comes, there's a AWS AppSync service which can be directly putting to the catalog, and that's where it will pull up all the flight details, and it will show up that these all flight options are available, right? And let's say you choose some of the flights, then it goes down towards the booking process, and then from there the payment gateway. And then again, as per the session, the user might have some loyalty points and all, so there is a module for loyalty as well. And then there is an automation and monitoring aspect inbuilt. Now, if this is kind of an architecture which I want to create, and again, you can go ahead and replace these services with anything which you want. All right, I have chosen them, but let's say for the front end, which you see, you want to replace it with something else, feel free to do that. The architecture will never change, right? And there are certain architectural patterns which basically fits our bill, and that's something which we need to focus here, that how we could ensure that such an architecture anybody should be able to create with ease. And we need some guidance, and these well architected framework pillars will come for our rescue. You want to see how? Let's see how. So I have chosen some hand-picked patterns, and the first one I'm calling it as a cherry pick pattern. So what happens in a cherry pick pattern? Imagine that if there are a lot of REST API calls which you're making, right? And what you want is, you want basically a single API, and then you have a UI, and then you want that kind of a GraphQL kind of a use case where you could build in, the app sync, which I showed you earlier, which you saw earlier. And you want this GraphQL kind of thing, which can accommodate all your API possible calls, which are possible for that particular architecture. And if we want to remove all the low level implementations, those headache from the end user, from the customer, how we could achieve it. Let's have a look. Maybe it will give you more clarity. So imagine this particular diagram in front of you, where we have an app sync, and then you have your resolvers and your data sources which are there. You have DynamoDB, which is a NoSQL database which contains the list of all the flights, all right, with their timings and arrival date and departure date and whatnot. And now if you look at the bottom part is something where I have embedded the well architected framework pillars as well. So now let's see, if this is the most simplest thing which you see, the bare minimum, the POC kind of an architecture, how we could go ahead and implement these well architected framework pillars for our benefit. The first thing is, if you want to do simple things, for example, you want to create something, you want to delete something, you want to update something, you want to filter something, you want to process a simple query. Again, you could use a VTL or Apache Velocity, and then you can use it, right? And AppSync can do that. But then the moment your complex logic comes, where you want to see, okay, from this region, how many people had booked a flight or tried to attempt to book the flight, or which flight is most popular, which timing, a lot of people comes, and you want to run some complex business logic on top of it. For example, how many of them have used application, how many of them used the computers, how many of them were customers, how many of them were agents or agencies, these kind of complex logic. What we can do is we can easily put in Lambda functions, and Lambda can handle that complex logic. The second thing, for sometimes what happens is, in our entire program workflow, we might have certain iterations. For example, I completed step 1, step 2, step 3. Now before I go to step 5, I have a step 4, but step 4 depends on a lot of if but or if while kind of loops, right? And that's where I can bring in the state machine, right? And the state machine is the same thing which you saw, the Saga kind of architecture, where I can use step functions, and I can integrate those logics which I want to use. So that is something which will take care of my reliability, because anything fails, okay, in the application logic, I can ensure that I have handled it properly, right? Now, I can involve Cognito, and this is something which will enforce the authorizations for your API calls from the security pillar. And let me give you an example for it. Imagine that you have a GraphQL and your app sync is there. And then, when somebody does a booking, you want to show them something, right? Like you want to show them the flight name, the timing, the dates, and all these things, right? The airports and all. But then you want to show something different to the agencies. Let's say there are some agencies which are also doing the booking. Maybe sometimes they're doing bulk booking, and you want to show them something else, right? And this is something where you can involve Cognito kind of a use case, where Cognito can go and show them those agency or agents or administrators some extra fields, right? And those fields will only be shown to those people who have got authorized, right? And that is something which I could do. I don't have to write a second program for it, because the same program, just using the authorization part, can show most of the fields which I want them to show. And for normal customers, it will not show those fields, right? The good thing is, the arrows which you see from AppSync to Cognito and all, they are all tightly integrated with each other. So you don't have to write even a single line of code to achieve this thing. Similarly, again, we started off with DynamoDB, if you remember this particular architecture. And DynamoDB, having the complete, customer details and loyalty points and all those things, or maybe flight details. And you can say, okay, which flight and what timing and what are the destinations and origin port and the destination port and all. But then once the booking has been confirmed, now I can put that thing into a relational database, because tomorrow this is something which is fixed. The order has been booked, the ticket has been confirmed, and now I want to put it in a particular schema, so that later on I can process it properly. I can even integrate RDS, or which is relational database service here, because DynamoDB is a NoSQL. And the bottom line which you need to understand is, this gives you the flexibility to use the purpose built database, because the most important thing which in the industry a lot of people don't understand is that no one size fits all, right? There could be time series use cases where you might have to use time stream kind of a database. There could be graph kind of a databases. There could be relationship based on a database where you will say, okay, I want to use Neptune, which is graph based database. Sometimes it could be a document DB where you'll go with MongoDB compatibility, or certain thing like that. We have our own document DB as well. And sometimes you will think about a quantum ledger based database, and that is something which QLDB can help you out with, right? So if it is like simple key value pair, okay, DynamoDB does a great job because it's a fully managed service, it's completely serverless. Number two, it gives you an SLA, and the SLA is no matter how huge is your data, and any query you run, you get a single digit millisecond latency, right? And that's something which makes it super fast. Similarly, when you talk about app sync, and this is something which is the hardest part of the engineering which we have done. uh, Again, when you talk about the REST APIs and you want to cache them, it's pretty simple and straightforward. But then that is not true with a GraphQL kind of thing, right? So imagine there's an agency, and they want to multiple times a day want to check certain things. And it could be like the agency employs several employees, and then they all probably try to hit the same query, and they get to see the same data. Can we use the caching? And that is something where an app sync, you can go ahead and enable caching, and that is something which will save a lot of cost or a lot of query cost to backend databases, right? So this is like one kind of an architecture. And again, you can only select that data which you require. For example, at the end of the day, how many bookings this agency did today, right? A simple query, right? But then many people might be running this query within the same company, right? Or maybe the same query tomorrow also the company will run, that okay, how many tickets did I book yesterday, right? And that's where this basically saves you a lot of cost because of the caching as well. Now, let me show you another use case. And this is something particularly important for a strangler kind of an architecture. So what is a strangler architecture? Strangler architecture means you are having a lot of commodity hardware, those things which you have been using for years and years. You have spent heavily for the hardware. And now, you want to modernize, everything, the entire architecture. So imagine that you have a bank headquarter, and then that bank headquarter has mainframes and Kafka and NiFi, and then you want to modernize the entire application for mobile banking. So you have customers, and these customers uses the mobile application. These customers have their own preferences, and they coordinate with the preferences section. So there is a module for preferences. And then, as I said, in the bank headquarter, they are connected via the direct connect to the cloud. They have a mapper function where the Kinesis does all the streaming of the data which is coming from the NiFi, and we have our own MapReduce, engine, which is EMR. And EMR, you can use multiple frameworks which are most popular in the industry today. For example, the Hadoop, if you want to use it, or Apache Spark, or maybe Presto or Hive or Pig Latin language you want to apply. All these are supported all over EMR. The best thing is this is on demand, which means I had the bank headquarter where I never purchased any, high-end servers, or the infrastructure for the big data analysis. I can still do the same analysis on the cloud. I don't have to buy the servers, because if I buy the server, it's always I have bought it. I have upfront put the money. That's just my total cost of ownership, and then I have to make those servers run all the time, which is not required on the cloud, because only when you have to run those analysis, only then you can spin out those servers, and then you can go ahead and process them, right? Now, we have a data service, and this data service module is something which takes care of the entire analysis part. And then we have an event engine which checks the customer preferences, and they have a messaging service and a notification service which sends the push notification back to the mobile customers, right, who are using that mobile app. And again, on top of it, you have the common services, you have some dead letter queues. What is a dead letter queue? And you will hear this term a lot in my this particular session. We have a service called as SQS. So SQS is simple queuing service, right? Now it's a simple polling service, which means anything can come into SQS, and then you have producers who are producing the stuff. They will put it in the queue. You have unlimited queue as part of SQS service. No infrastructure to manage. It's completely serverless, and clients can come and pick it up one by one from the queue, process it, and then go ahead and delete it. However, there could be certain data which the clients are not able to process, which means that data will remain in the queue forever in that case, right? So for that particular purpose, we have a special kind of a queue. We call it as DLQ, or dead letter queue. So anything, any messages which you are not able to process, they goes to the dead letter queue, and then you can manually go ahead and massage them the way you want, or maybe you can flush them out if you want, right? So that is something which we could incorporate. So let's see the strangler pattern, right? How we could enable the same well architected framework pillars in the strangler pattern. So here we start off with the corporate data center, which had a load balancer, and then at the back end they had servers and databases and all, and clients were communicating with them. Now what we did, because it's a mobile application, we are going to incorporate the API gateway. An API gateway can take care of all the API calls. And then we create an infrastructure where, again, we will be putting the load balancers, and then we will put, we'll take care of our operations. Number one, when you have to put it on the cloud, you will be thinking about how we could centralize the logs, how we can take care of the matrices, can we create our rules, how do we collect the tracing information, for example, the forensic information, like who did what at what time, right? Those kind of things. Similarly, we will use a corporate load balancer to send the IP traffic, and we can put our own authorization. So again, it could be anything which you are already using, or you can create a separate module for it. And then from the performance perspective, we can gradually and slowly shift the functionalities to the latest modernized services and application supportive infrastructure components, because this is something where we have the basic architecture ready, and now slowly and steadily. So example, we had a web server, right, which was running across 4 or 5 systems on my physical infrastructure. We will slowly migrate them, lifting and shifting them onto the cloud, and then we'll be running them on EC2s or Lambdas, or if we can completely offload it on, let's say, containers, maybe that is something we could look at it, right? Next, we will go ahead and use all these serverless technologies like Lambda and DynamoDB for latest functionalities, right? And we can reduce the cost as well. Just to give you an idea about the cost, AWS Lambda, many of you might have heard it, and definitely if you are from developing background, you definitely must have heard it. Lambda is a serverless compute. And as per the free tier, we provide 1 million Lambda instruction free for every customer every month, lifelong. It's not for 1 year, it's lifelong. 1 million Lambda instructions are free, right? Similarly, 25 GB of DynamoDB is free, lifelong. So you need to understand that one Lambda instruction can go till 15 minutes of execution, right? And that's where the cost comes down. Let's see another pattern, which is the most popular, which is, we call it as comfortable rest. So imagine the restful APIs, right? And the basic architecture where you see we will have an API gateway, we'll have some Lambda functions, we'll have some DynamoDB, which is the backend. Now, if you look at it, the API gateway becomes like kind of a front end which manages all the logic. Then you have the Lambda function, which is doing, all the jobs. And then you have the backend DynamoDB. This architecture is kind of a pilot, the POC. It is the most simplest thing which you can have, with which everybody starts off with, right? Now let's try and incorporate the best practices. So here, from the operations perspective, again, we'll enable the logs, centralize the logs and all, and then we'll ensure that our matrices are also being taken care by the CloudWatch. We also, from the reliability perspective, because see, these are restful API calls, and as an application owner, we should be aware of how many maximum API calls somebody can hit in my application, right? You will have some idea, right? You will say that, okay, maximum concurrent, I'm talking about 5 API calls or 10 or 20. You will have some numbers. Now, you don't want to pay for additional API calls which are being hit by some bots, right? You don't want to come under that kind of a scenario where you are having hundreds and thousands of API calls which are coming because of bots, or maybe because you are under attack. Can we regulate the inbound and outbound rate, right? So that is something which will bring in a lot of reliability. Similarly, we can have authentication modules, Cognito and secret manager to store all the secrets and all. From the performance perspective, we can choose DynamoDB on an on-demand basis. So how do we ask you to configure the DynamoDB? We just ask you two things. We don't ask you about the compute, how much CPU you want, how much memory you want, how much storage you want. We don't ask you these things. We just ask you how many reads and writes you want on an hourly basis, and we charge you based on that. Now imagine this is a new application and you're not sure how many reads and writes per hour will come, because whatever you will configure, you'll be billed accordingly, right? Whether you consume those many reads and write capacity units or not. So we have enabled another feature of DynamoDB, which is on demand, which means you don't have to specify even any numbers. You can just choose on demand and you'll be billed only based on the actual charges which are there, right? So that is something which we can do. And we can definitely, if it is the regional service, we can use the regional endpoints to support your HTTP/2, right? And again, we can use the Lambda power tuning. So what is Lambda power tuning? When you configure Lambda, although it is serverless, but then you have to choose the memory, and you can go from 128 MB of RAM till 3 gigs, and as much memory you will go ahead and configure it. We will provide you the CPU and the IOs and network, everything accordingly in proportional to that memory which you have selected. Now, many a times, a lot of people believe that, okay, if we go with more memory, because there are many compute operations or commands which doesn't require much of the RAM, right? 128 MB works absolutely fine for most of the things. But then sometimes you will believe that, okay, maybe if I increase the memory, because Lambda is auto scaled by default at the backend. And when you talk about, let's say I want a total of, let's say, 50 gigs of memory. Now what is the combination? Are you going with 50 GB divided by 3 GB? Let's say each Lambda will be 3 gigs. Or should I go with lesser RAM? Okay, and then still I can beat the cost. Because what happens is, after 1 million we start charging you. 1 million is a huge number, I agree, but it is for the whole month. Not sure how many API calls will be handled by the Lambda functions, and maybe you'll start getting charged. And that's where we have a feature called as Lambda power tuning, which will do a performance to cost kind of a tuning for you. And again, this is something which will tell you the most appropriate memory or configuration for the Lambda, so that you are not incurring the huge cost, right? And that is something which we could use for any RESTful based architectures. We have another pattern which is I call it as CallMe maybe. What do you mean by that? This is specifically for the webhooks. Now imagine kind of an GitHub kind of a use case. Let's say you have uploaded something on the GitHub, and then you are waiting for a message to come back which says check-in successful. Or maybe think about a Slack kind of an application where you have sent some message and then you are waiting for the response, right? And we use webhooks for that. So again, we start with a very small architecture, simple design. We have API gateway and Lambda, and again, just for the love of RDS, I have put RDS this time instead of DynamoDB. But then what you need to understand is how we can ensure that even for a webhook kind of a use case, we can ensure that we have all these pillars. So again, we can use the concurrency limit in the Lambda. We could do that. We could say that maximum the Lambda can go till 5 or 10 from the auto scaling perspective. But then here, what if your actual use case goes beyond that concurrency value? So what we can do is we can use Kinesis, and Kinesis is something which can create a batch or a kind of a buffer and then process it towards the Lambda, right? So this way you don't have to set the limit on the Lambda, whereas Kinesis is something which can take care of it. And again, anything which you can't process goes into your dead letter queue. And again, if there are some data which is very critical and you don't want to show that data, when it is stored in a plain text in databases, you can add another functionality which is obfuscating that particular data. So imagine you have some secrets, you have some credit card numbers or some sensitive data which you want to obfuscate, and that is where we can have a Lambda directly attached to the Kinesis, so that when it is streaming, then and there it can get hidden and then it goes to the processing, right? Similarly, for the low volume traffic, you can configure the Kinesis for a maximum of 5 minutes of a batch, so it will wait for 5 minutes before you flush that particular stream or shard, and then it goes to the Lambda, right? And again, the same thing I could have done using SQS as well. So these are two separate webhook architectures. If you see, at the top one you have an API gateway, and then instead of Kinesis you directly have a SQS, and then you have the Lambda and DynamoDB. In the bottom one you have Kinesis and Lambda and then RDS. So your choice, your call, which one you want to go for. Similarly, we have the big fan, and this is something where we can fan out. So imagine you have a simple notification service, and which is picking up the API calls from the API gateway, and then you are kind of processing it. And this could be for the status of the flight booking, let's say, whether the flight booking has been confirmed, whether it has been cancelled, or whether it is still on queue or in progress, in process, something, right? And again, if I want to scale it in a fan out architecture, I could do that. What I need to do is, instead of putting the Lambda directly, I replace it with a queue so that I can forward it to multiple Lambdas for multiple customers, right? And this is something where I can directly, using the SNS service, I can create a booking status, and that status could be created, it could be processed, it could be refunded based on whatever logic you want to put it. Because you are using the SQS queues, unless and until the Lambda will go ahead and process it, your data will not be lost. The data will be present in the queue because it's a persistent service. So we can use message filtering, and then we can compress and aggregate the messages whenever they are possible, right? So that will remove the overall usage. And again, if you want, you can consider Kinesis if you have larger payloads. So this is a second variant of the fan out architecture. The last one we have is for the streaming use cases. So this is, they say I am a streamer. So imagine you're using Kinesis, which is for the streaming, and we use Kinesis data firehose. And this is something which will do some kind of an ETL activity and then put the data in a persistent storage like S3. Now, enable, if we want, the whole stream to have the entire records and all, we can even have a, backup S3 bucket. So directly Kinesis firehose can put the data into two S3. One is the main S3, then there is a backup. Why we are taking a backup? Because maybe this data we want to go ahead and further analysis using big data architectures. Maybe we can use this as an input, or maybe there could be other reasons where I want to store the data in a particular format, or maybe I want to store the data in a particular region for the DR perspective, right? There could be multiple reasons. But if I can do that, what I can do is I can have dedicated data firehouses which are for different context. So I can say that, okay, if it is, let's say, slash orders, you go to a different fire hose. If it is, slash home, you go to a different fire hose. If it is like slash cart, you go to different fire hose. And I can have multiple S3 buckets which are dedicated for those fire hoses. Similarly, I can enforce the authorization. I can remove the sensitive stream of the data, obfuscate it then and there at the input streams itself. And I can, if I want to further process it and I want to further query it, I can, change the format to a Parquet or an ORC kind of a format, which is columnar splittable databases. And these are something where I could run the query using Athena, which could be a serverless querying engine directly on the S3, and I can retrieve some analysis out of it, right? So again, if we want to save the cost as well, we can use the message filtering to prevent unwanted events, and I can have better compression and buffer ratio, right? So there could be, and I do agree, maybe this is something you might not have even thought about it, but just, keep an eye that you might have a use case. Imagine that you are creating a project when there is an election, and you are trying to find out what is the general sentiment and how you could do that. Just use the Twitter feeds, stream them, and then use some machine learning algorithm on top of it, which can even tell you what is the sentiment of the Indian public, right? And this is a very simple use case where this architecture could be used for that particular purpose, right? And again, if you want to, go to a global scale, I can use, Lambda at the rate edge, I can use CloudFront, and I can use the edge level caching as well. So overall, now if you look at it, how we could use these best practices across analytics, ML, user engagements and all, I can just think about a couple of things. Number one, decouple the entire architecture. Use services. If you're, talking about microservices, you can think about SQS or SNS or Event Bridge. Again, SaaS integrations, Event Bridge is a great, tool over there. If you have cloud modernization or migration or maybe multi-cloud or hybrid kind of architectures, then Amazon MQ or MSK, which is Managed Service Kafka, can come into for your rescue for decoupling purpose. We have another service called as Pinpoint, which is used for targeted messaging. I'll give you a very simple example and you'll understand what I'm talking about. Do you guys receive let's say SMS where somebody says about some offer? Now imagine there's an ice cream parlor which is there near to my home, and if I'm in Hyderabad and I'm getting an offer, let's say discount sale which is happening, great, maybe I'll go there and avail that offer, or maybe I'm not. But then I will get really frustrated if I'm not in Hyderabad, I'm not even in India, and still if I get that message, right? So this is something which starts working at spam. We do have a service called as Pinpoint, which can do targeted messaging. So imagine now, where is this ice cream parlor? If let's say it is on 100-foot road, and if your vehicle comes into that 100-foot road, and then your GPS data is on, and then you have that app of that ice cream parlor, and only then if you get a message that in the next 10-15 minutes, if you come, we will give you 40% discount, what is the chances that that person will stop for 2 minutes, avail that 40% discount, and get the ice cream, because you have reminded him or her exactly at the right time when he should get the message, right? And that is what Pinpoint can do. And one of the architectural patterns, you have multiple services for messaging. We can talk about emails, SMS, push, voice and all. You have Pinpoint, which is the targeted messaging service. You have Kinesis data streams, data firehose. Ultimately, the data comes into S3 bucket where you do some processing of that. And then I can further add the machine learning to it. I can use the SageMaker service here. I can train the model, and then I can create a complete event-driven system using the step functions, using querying with the Athena, and using the Glue for the crawlers, which can go ahead and find the metadata from my service. And this entire thing is something for leveraging the entire social media for real-time engagement with Pinpoint and Comprehend, right? So I know maybe I have talked very high level. I've talked about a lot of services which probably some of you might not even have heard about it, but then I'm pretty sure all of you might have taken a note of it. And this is where I'll stop, because what I wanted to tell you was, if you keep these well architected framework pillars in front of you, and then you go ahead and approach your architectural designs, this is something which will kind to reach to the end result in a very beautiful way. So that's where I'll stop. And if you have further any questions you want to discuss with me, my contact details are available for my email as well as LinkedIn. uh, and that's where I stop, and I hand it over back to the CSA chapter team. Over to you.
If you have questions, you can kindly write those in Q&A session. We would be taking the questions for next 10 minutes. Saurabh sir, there is a question that what is NiFi? Am
I'm
I audible?
sorry. I'm so sorry. It basically happens a lot when you are on
Okay.
mute and you start speaking about it. All right.
Okay.
My bad. All right. So NiFi, see, NiFi is a from Apache Foundation, and it's a software project which they have designed it to automate the flow of data between the software systems, and it is the name is coming from Niagara files and all. So again, that's from where it is taken, and it was previously developed by NSA, which is the also the source part of the present name of NiFi, right? So anywhere where you have the data flows which you want to manage, NiFi is one of the open source tools which you have.
If you have any more questions, you can write in Q&A section. So the next question we are having, sir, is what is M4 large instance and how do we change that instance? M4 large instance.
All right. So see, what we need to understand is in AWS, we have multiple EC2 system types. All right. And this is something each of the instance type pertains to one of the categories. We have multiple families like general purpose and then compute intensive and memory intensive, and then we have storage intensive and graphics, accelerated graphics intensive and all. And what we need to understand is M4 is something which is, one of such family types. All right. So we have these different instance types which comes with different permutation and combination of CPU and memory. All right. And when we talk about M series, this is something which if you go to the number after that, so M stands for, let's say, the general purpose category, which is high on memory, and then the number 4, 5, 6 and all these represents the latest generations, right? So M5 for example, or M4 if you talk about, or even M6. So M5 and M6, these are the latest generation. M5 is specifically for general purpose for Intel Xeon, which goes with Pentium 8175M processor family, and again gives you a balance of compute and memory and network and all. So if you talk about, let's say, one of those instance types, let's say M5, which is provides you kind of up to like 3.1 gigs of Intel Xeon processing speeds, and you have newer larger instances like M524X large, which can go till 96 CPUs and maybe up to 4 terabyte of RAM kind of thing, right? And it'll have like up to 25 to 50 Gbps of network bandwidth. So these are the instance types.
So a lot many questions are pouring in. One of the questions from Ganesh is, what are the patterns you suggest to use for moving existing systems to cloud? What systems should we move to cloud?
Okay, see, I would not suggest any patterns to move the data to cloud. What we need to understand is we need to look at it as a migration activity. And when we talk about the migrations, we can talk about migrating the systems. And over there, first, we have to do the portfolio discovery where we need to understand what is the scope of migration. Then we have to understand which of these applications can be, they are ready for the cloud, they're cloud native, and we can use a strategy like lift and shift to migrate them to the cloud. Some of the applications, maybe while we are migrating, we want to change their platform. So for example, let's say I have a Windows Server 2003 operating system, and I know that it is old and maybe its support is not there anymore, and I want to migrate the application, but then I want to also change the operating system underlying. So maybe I have to do some kind of like re-platforming, right? So the first scenario was a rehost where I did a lift and shift, which was ready to move to the cloud. The second one is called as re-platforming, right? The third one could be that my application is completely, let's say, monolithic, and this is something where you have a lot of tight dependencies and all, and you cannot move it to the cloud. And maybe I will go ahead and completely re-architect the application, convert it to a maybe microservices kind of an approach or containers, and then move it to the cloud. I will call it as kind of re-architecting, right? Some of the systems I will retire simply because I will say I don't need it on the cloud anymore. And some systems I can't migrate to cloud and I will retain it on-prem, and I'll call it as like, okay, I'm not migrating it. I will run this application only from the on-prem data centers. So the R's which I talked about, these are the strategies which I will use for migration. These are rehost, re-platform, re-architect, or you can call it as refactoring if you want, and retain and retire. Now, this is about the applications. The second thing is how would you migrate the data, and then how would you migrate the databases. So databases part is simple because we have a DMS service, which is database migration service, and you can use any service from any third-party tool as well. You're most welcome. And then try to migrate the databases. Data migration can happen via offline mechanisms, via like Snow Family. We have Snowball Edges and Snowmobile and all, or Snow Cone, or online mechanisms, maybe VPN and Direct Connect and S3 transfer accelerators, and maybe data sync, or maybe cloud endure. There are multiple ways how we can migrate the data, right? So I would suggest these are some of the mechanisms which you have to look into, and maybe these are some things which will help.
Thank you, sir. Then another question is the Lambda operation a backhand service provided like a virtualized solution?
No, see, it's not a virtualized, it's serverless. So as I said, let's say right now you have a laptop, right? Or maybe a computer, and you need to understand it like this. Why you use the computer? Let's say you are saying that I am opening my computer, and my computer has some specification like CPU, memory, network, and all, and hard drive. And then I want to, let's say, do a calculation of what is 2 plus 2. Let's say this is why I'm opening my computer. The problem is, if you can do the same thing with EC2s, right? But then first what you have to do is you have to create an EC2 where you have to define the CPU and memory and OS and all these things, and then wait for 5 minutes for it to boot, and then you log in, and then you run to what is 2 plus 2, and you will get the answer 4. The great thing with Lambda is it is exactly like a computer, without any of the hassles which I said. All you have to do is just upload what is 2 plus 2, and it will give you an answer as 4. So Lambda is not like kind of any virtualization or anything. It's serverless, which means there is a computer behind the scene, but then you are not responsible for it. You're not managing it. All you have to do is upload all your commands to Lambda. Lambda will execute it. As simple as that, without the headache of managing a computer, creating it, making it highly available and secure and scalable. You have no headache. You just do the same task which you used to do the same way how you used to do, without the hassles of creating, managing, operating the stuff, right? So that's how I look at it.
So the last question which I'm going to take is Jafar Sheikh is asking that how Python can be used in AWS automation.
Okay, see, when we look at the entire AWS, and we are talking about close to 7,000 odd services and features, it's inhuman to become expert or even go through all these 6,500 plus services and features. And what we can do is whatever we require. Let's say if I want a compute kind of a use case, then I can go dig deep about what are the compute services and all, right? And the same thing I can do it if I'm interested in storage services or networking services or databases services or AI, ML, and data analytics services and all. What we need to understand is if we know some programming language, right? And any service in AWS, you can manage it in 3 ways. Number one is via the GUI way, which is the management console. Number two is via the command line way, which is via AWS CLI or AWS command line interface. And number three is with your APIs and SDK. So if you are coming from Python background, you can use the Boto 3 SDK and you can create your API calls and you can manage all these services and features, right? Whichever you are interested in. So that's how I will, close it. And another thing, folks, again, I think we are already running out of time. So I have already shared my, email and LinkedIn. Feel free to connect with me, and maybe I can try to help you out offline as well. All right. So thank you.
Thank you, Saurabh sir. On behalf of UPES CSA chapter and the Department of Virtualization UPES, I, Avita Katal, will like to extend a very hearty vote of thanks to you for finding the time from your busy schedule and sharing the knowledge of AWS with us all. We look forward for such more interactions with you. Uh, Thank you so much, sir.
Thank you, ma'am. And it's my pleasure. And for everyone out there, the next 2 Saturdays also, my colleagues are coming and you'll have some gala time with them. I think next week, Suraj is coming, who is my, mentor and manager, and he's going to talk about some fabulous use cases on AIML. Just, stay tuned. Same time, 4 to 5, and stay tuned for them as well. Thank you so much, Avita, and, Vitesh, who helped me and brought all of us together. So thank you both.
Thank you, sir. Now we will be having a quiz session. So Vitesh, you would be taking over, right?
Yes, ma'am.
Okay.
So, good evening, everyone. I hope you have all enjoyed the session. Now, are you ready for the quiz? Okay. First of all, I will tell you the rules for the quiz. I will share my screen. Give me a minute. Okay. The quiz will be held on the Kahoot platform. You guys either can install the application or you can easily go to the play.kahoot.it for start the quiz. Is my screen visible to all of you?
Vitesh, can you write the link of Kahoot onto the chat so that all of them can get in?
Yes, ma'am, sure.
All of you can log in computer systems. The questions will be seen on screen that would be shared by Vitesh, and you have to answer through Kahoot. The pin for the same is Vitesh. Kindly share the pin also.
Yes, ma'am.
Okay, guys, the pin is on your screen 44495952. You can go to the required link which is there in the chat, https play.kahoot.it or .it, and you can join in with the pin which is on your screen. We are going to start with the quiz in a few seconds. So we have only one player over here right now. Let's wait for others to join in quickly. We are waiting for all of you. You go to the required link, Ishika Single, right? The link has been shared. That is www.kahoot.it. You can join in this link and the pin, Saurabh, kindly write the pin again. And the pin is 44955952. We still have 29 players in house. We're waiting for the rest ones to kindly join in. Uh, Arvind Kumar, kindly try again, Arvind. I think we should start. I think we should start. We have waited enough. We have a time limitation also. So, Vitesh, let's start with the quiz.
Okay, ma'am. So let's start.
So the first question is on your screen, and you would be having limited amount of time to answer it.
So first question is, AWS well-architected framework is based on how many pillars? You have 4 options, 3, 5, 2, and 6. Please check the color code and symbol in your app.
You have to check the color code. The answers won't be visible, but you have to check the color code. The red is for 3, blue is for 5, yellow 2, and green is for 6.
So the answer is 5. We'll move to the next question. 31 got it right. Congratulations. So here is the leaderboard. Tahir Javed is on number 1, followed by Saksham, and then you don't know me.
Kindly write your appropriate names.
So here is the second question. Dash is used to identify a set of components that together deliver business value. Red color is for load balancing, blue for cost optimization, yellow for workload, and green for component. Okay. Here are the reports. 17 got it right. Congratulations. Now the leaderboard has changed. Tahir Javed is on top. So let's move to the next question. So here is the question. Each AWS region is composed of 2 or more locations that offer organizations the ability to operate production systems. So red is for availability zones, blue is for application areas, yellow is for compute centers, and green for geographic districts. So 38 got it right. Congratulations. Tahir Javed is still on number 1. Moving on to the next question. Which of the following are minimum required elements to create an auto scaling launch configuration? So here are the options. Red is for launch configuration name, Amazon image and instance type. Launch configuration name, Amazon instance type and key pair for blue. Yellow for launch configuration image AMI instance key pair security group, and green for launch configuration name AMI type key pair security group, etc. So 13 got it right. The answer is A, launch configuration name, Amazon image, and instance type. Here is the leaderboard. So the next question is, what is the format of an IAM policy? Red for XML, blue for key value pairs, yellow for JSON, and green for tab delimited text. So 30% got it right. Congratulations. Here is the leaderboard. So the next question, how many access key may an AWS identity and access management user have active at one time? Red is for 0, blue is for 1, yellow is for 2, and green is for 3. So 26% got it right. The answer is 2. Here is a leaderboard. The leaderboard has changed now. So let's move to the next question. This is question number 7. Which of the following is the name of the security model employed by AWS with its customers? The options are red for the shared secret model, blue for the shared responsibility model, yellow for shared secret key model, and green for secret key responsibility model. So 32 got it right. The answer is shared responsibility model. Here is the leaderboard. Okay, let's move to the next question. The question number 8. What is the name of the feature in VPC? VPC stands for Virtual Private Cloud, that allows you to launch EC2 instances on hardware dedicated to single customer. So the options are red for Amazon VPC based tenancy, yellow for dedicated tenancy, blue for dedicated tenancy, yellow for default tenancy, and green for host based tenancy. So 24 got it right. The answer is dedicated tenancy. So we have the podium. So very congratulations to all the top 3 participants. First one is Pratyusha, second one is Yakshum Makkar, and third one is Astha Kumari. Thank you all for participating in the quiz. The top 3 performers will get the NVIDIA DLI training course worth $90 for free. Over to you, Avita ma'am.
Thank you, Vitesh. Congratulations to all the performers. As you know that in AWS Learning Series, we are having 3 sessions. The first session was today, and the next session would be held on 19th of September, and then the third one on 26th September. We have very good speakers, esteemed guest speakers on both the days. We will share with you through email the Zoom links for joining those sessions. Thank you all. See you in the next session.